Jared Harrington, and today I will be discussing Lab 5, Faraday's Law. So, a quick overview of this lab is the purpose was to gain a greater understanding of Faraday's law by examining the observational data of a magnet falling through a tube of aluminum foil. The system in this case would be the magnet and the aluminum tube, and the surroundings would be everything else. The results found were in the experiment, it took 1.69 seconds for the magnet to fall down the tube, and in the computational model, it took 1.645 seconds. So some important physics principles are Faraday's law, the Biot-Savart law, which is this equation, magnetic flux, Newton's second and third laws, and magnetic force. And then here's my sister doing the experiment. So, for the observational data, the length of the aluminum foil was 0.45 meters, the width was 0.01 meters, and the inner radius was 0.02 meters. The mass of the magnet was 0.025 kilograms, and the dipole moment, or mu, was 2.13, and this was determined from lab 3. And then the average time was 1.69 seconds. And then for the computational code, here are some of the values. This is the starting values. This is the values for the aluminum foil tube, and then this is the values for the magnet. Um, in this function, I determined the magnetic field of the bar magnet, and then this function, I determined the magnetic flux. And then from here, I got the gravitational force, and then this section right here calculates the magnetic force from the tube to the magnet, and then this section here calculates the B field, and this one is the net force of the magnetic field plus the gravitational field. And this function is Newton's second and third law being applied. So overall, the computational model found that it took 1.645 seconds for the magnet to fall down the tube of aluminum foil. And this is slightly reduced from the experimental model, and this is largely due to sources of error, but also the computational model depicts a perfect scenario of the experiment, and this is not the case as air resistance is an important factor in the experiment, and this may have caused the magnet to take slightly longer, even if it is a minor amount. So some possible sources of error are this measurement of time, meaning I may have recorded too early or I may have stopped it too late, and I may have angled the magnet wrong while it was dropping. And then inaccuracies with the magnet. I said this even though it wasn't the case, but if a magnet was broken, this would affect the magnetic field and could cause the magnet to take longer or shorter to fall down the tube. And then for our first what if question, if the resistivity of the conductor was as close to zero, this would cause the current to increase due to Ohm's law, and it would also result in the magnetic field and force increasing, which means it would take longer for the magnet to fall down the tube. And then in the second question, it would be the opposite in this case because the current would decrease, which would cause the force to decrease and thus cause the magnet to fall down the tube quicker.